In these problems, we're going to be solving equations that start as logarithms, but notice that in each of the problems here that we're going to be looking at, that the x is actually located inside of the logarithm. So here, if we want to try to get the x by itself, it needs to be out of the logarithm for me to be able to do that. The only way to switch something out of logarithmic form is to exchange its form from the equivalent version of it in exponential form. So let's see what that would look like in this problem here. The x is trapped inside the logarithm, so I'm going to switch to exponential form. We always start by writing the base, which is the small number here. In this case, that's 3. Zigzag over to figure out what the exponent is. In this case, that's 4. And then that should be equal to what this number here is. So we're just rewriting the logarithmic equation in exponential form. And again, the advantage of this is now that the x is not stuck in the logarithm anymore. It's out, it's alone, and it's ready. On the left-hand side of the equation, we have 3 to the 4th, which doesn't have any variables with it. We can just figure out what that is. 3 times 3 times 3 times 3 is 81. And there is my solution. Don't forget that you can check this by plugging your value in for x. You go log base 3 of 81, and you can evaluate that on your calculator using the change of base formula. In this case, the log of 81 divided by the log of 3. And we should get 4, which we do. All right. So, and that's basically the gist. If your variable is stuck in the log, you need to change it to exponential form. Of course, you have to have just the log expression. So remember, the log expression is the log, the base, and whatever comes after it on the main level. So this needs to be by itself before I can switch it to exponential form, which means that the 15 is in the way. Right now, because there's nothing going on between the 15 and the log, it's assumed that it's multiplication. So we're going to get rid of that 15 by dividing by 15 on both sides. So in this case, I'm going to have log of base 3.2 of x minus 7 equals 10/15. Now, because I'm going to be writing my answers for logarithms in terms of decimals anyway, I'm going to go ahead and write 10/15 in decimal form, which is 0.6 is repeating, right? So I'm going to just go ahead and, again, I really recommend that you take things out to 4 digits after the decimal. When we're dealing with exponents, having that extra level of accuracy is important because small differences can end up actually being very large when we're talking about powers. You could also just leave this as 2/3 and work with it as a fraction throughout the solving process. Now that I'm at this point, notice I have my log with my base and a value equals something. I want to get what's inside the log out, so I'm going to have to switch it to exponential form. In this case, then, we start with my base, which is the small number here, so that's 3.2. My exponent, we're going to use that 0.6667. And this is going to be equal to x minus 7. So I'm able to bring my variable out of the logarithm, and everything that's in there is over on the other side of the equation. On the left, I have 3.2 to the 0.6667 power. We can just go ahead and do that here, 3.2 to the 0.6667 power. And again, we might be off in terms of a 10,000ths position or something like that because of rounding differences. Here, that gives me 2.1716. And on the other side, I had x minus 7, which is what was located inside the logarithm here. The x is not quite by itself yet. There's a minus 7, so we just need to add 7 to each side. That will finish getting the x by itself and get me my solution of 9.1716. All right. Our last example here on this video, we're going to need to find, we want to solve for x in the log of 2x plus 1 is equal to 2.4. Right now the x is trapped inside the logarithm. The only way to get it out is to switch this to exponential form. When we go to switch to exponential form, however, notice that there's no base associated with my logarithm, so we assume this is their common log and it's always base 10. If it helps you to write that in, write it in, because now when we go to write it in our exponential form, the base is 10, my power is 2.4, and then everything that was inside the logarithm is now alone on the other side of the equation. So this is the exponential version of that same exact equation. We can find 10 to the 2.4 power here on the calculator. 10 to the 2.4 power is 251.1886. equals 2x plus 1. And now notice that the x is not trapped in anything. We just need to finish getting it by itself with our normal standard solving procedures. So we'll subtract 1 from each side, which is going to give me 250.1886 equals 2x, and then I can finish solving just by dividing each side by 2. In this case, the x will get by itself, and on the left I'm going to end up with 125.0943 as my solution for x.